Hello, everybody. Today, I'm going to walk you through an exercise where you can learn about how you can use OSIsoft Cloud Services to remotely monitor your assets. My name is Dinesh, and I'm going to be with you for the next 60 minutes in terms of walking you through the process of how you can use OCS, also known as OSIsoft Cloud Services, to to be able to monitor your assets. Um, So this is meant to be a session where I will walk you through the steps of how you can configure a data collection mechanism to collect data from remote assets, send the data to OSIsoft Cloud Services, process, and how you can use OSIsoft Cloud Services to automatically build assets and finally be able to visualize them using OCS trending functionality as well as using Grafana. Um, you're not expected to follow along, but you're more than welcome to participate in this forum and post your comments, feedbacks, as well as questions in the chat over here. I'll first start off with introducing what is all remote monitoring is about, and then I'll slowly get into ways of how you can configure a data collection uh, software such as Pi adapter for MQTT to be able to consume data from a subscribe data from an MQTT broker and send that data into OCS. Then we will deep dive into these different features and functionalities of OCS so that we gain a thorough understanding of how the streams, the assets are modeled, and also how they can be visualized in real time. It's going to be a little packed session, so stay tuned and get ready with the journey. First off, let's start off with what is remote monitoring. So for the next 60 minutes, I'm going to typically talk about what remote monitoring is all about, the typical strategy that companies follow, followed by a use case, which is remote monitoring of assets, more specifically mining truck assets. We'll then talk about how you can configure adapter for MQTT. We will then look into OSIsoft Cloud Services and see how those streams are created. We will learn how metadata rules can be created, how we can build an asset type, and then create asset rules, and finally be able to monitor and manage the assets. Finally, we will also get an opportunity to visualize the data using uh, a trending functionality within OCS as well as using Grafana. Let's understand how a typical remote monitoring strategy looks like. I'm not going to spend too long in this one, but just to get you a basic idea of how typically organizations embark their remote monitoring strategies. It's a six-step process going from the identification of a business objective, going to profiling your assets, understanding the type of your assets. And third, you would have to determine if there are any additional components that are required that are to be included as part of this remote monitoring strategy. Fourth, understanding your data. And fifth, defining the various business rules. And finally, to operationalize the values, any insights that you derive out of them, you need to loop them back into your operational layer so that your ultimate business objective is achieved. As I said before, the use case that we are going to focus today is related to mining, more specifically mining trucks. This is a fictitious use case where we're going to model a number of mining trucks operating in the field and how you can collect data from those mining trucks connecting to this onboard vehicle sensors accessible through an MQTT broker. In summary, we have those different mining trucks and an ultimate job task here is to see how we can model a data flow pattern that can connect to those vehicle sensors, subscribe to those values, and send those values to OCS. Towards through the course of this particular session, we will be seeing how you can get all those assets monitored in real time. We'll also be able to look into the behaviors of a specific asset. And finally, be able to visualize those streams of data using OCS trending functionality, as well as in Grafana. So that being the flow of the use case, what we're going to talk about, I think it's important we understand the terminologies of Pi system, which has evolved over the last few years. It is important that we understand the basic terminologies of Pi before we deep dive further. There are three main buckets, namely Pi Core, Pi Cloud, and Pi Edge. Pi Core is all about the Pi server components, Pi Vision, all those components that you typically use in your plant facilities to be able to collect, store, um, add Oracle data to it, and be able to analyze and present that information to the various stakeholders of your organization. Pi Cloud, on the, it's more it's on this SaaS side of things, where you have OSIsoft Cloud Services, Pi Cloud Connect, providing you the ability to store, analyze, as well as build hierarchies or add metadata to those streams completely within a SaaS layer, software as a service layer. Moving on to the third bucket, which is the Pi Edge, the category of products which fit into this category, which into this bucket, are more focused on collecting data from remote devices, places where they are not typically connected to conventional control systems. An example of that is Pi Adapter, which we're going to focus quite heavily today. Edge Data Store, also known as EDS, also fits in under this category, providing you the ability to store and store data at the edge and providing the operators at the edge the much needed visibility into uh, greater, deeper insights and analytics at the edge layer. Because Pi adapters is going to be the Pi adapters and OSIsoft Cloud Services are going to be the focus today, let's get a detailed understanding of how these Pi adapters work. So Pi adapters, these extend the data collection capabilities to remote, rugged environments. As a long-standing user of Pi system, you would be more than familiar with the Pi interfaces and Pi connector suite of technologies. Pi adapters are meant to help you or facilitate your data collection process from sources which are not typically connected to primary control systems. They can be installed both on Windows as well as Linux environment, and also as well they can also be containerized. Today we have a number of Pi adapters released that can talk to a number of data sources, and being able to natively support the publication of data to Pi server, to Edge Data Store, which we briefly talked about, as well as to OSIsoft Cloud Services, which is going to be the another focus for today. More specifically, we're going to be working on an Pi adapter for MQTT. We're going to be leveraging Pi adapter for MQTT because we'll be using that to subscribe to an MQTT broker and send that data into OCS. Um, it's a brief architecture of Pi adapter for MQTT. Um, Typically, having those data source components, the ingress components, and the data egress components. Again, in the interest of time, we won't be able to go deep into the specific architecture, but watch out for the documentation that carries more detailed information about adapter for MQTT. Another major component that we'll be walking through today is OSIsoft Cloud Services. Um, OSIsoft Cloud Services is a sequential data store, completely cloud hosted, managed by OSIsoft, which is now part of Haviva. It's a bunch of microservices, again, at the ingress layer, the storage layer, the analysis layer, the asset modeling layer, the visualization layer. So you get to store your data, you get to manage your streams, you get to model your assets, you get to auto create the assets and visualize those assets all within a cloud layer using your REST API call by a different REST API calls. Um, Products such as Pi Adapter and EDS can natively send data to OCS using OMF as the means. Um, and then if, if you're using Pi Server in your plant-based systems, you can also leverage Pi to OCS agent to transfer all or subset of Pi system data from Pi Server to OCS. So more about that again at a later time. In the interest of time, we're going to keep moving uh, um, as we get into the data flow architecture. So at this point, let me revisit the use case. The use case is all about collecting data from 10 mining trucks. Each mining truck is emitting about 10 different attributes, 10 different variables through onboard vehicle sensors. And all these data have been simulated, and which means 10 mining trucks, 10 attributes per truck. You got 100 streams of data or 100 attributes all being published into a Mosquitto MQTT broker, which is this Mosquitto MQTT broker. Today, we're going to learn how we can use these OSIsoft components, namely Pi adapter for MQTT, to subscribe to that MQTT broker and send that data natively into OCS. Once we do that, we're going to see how you can use the various features of OCS and learn how we can analyze, to manage, or to create the assets, visualize those assets in real time. So the focus of today is these two products, namely Pi Adapter for MQTT and OSIsoft Cloud Services. We have the data simulated between the sensors, publishing those data into the specific Mosquitto MQTT broker, which we'll understand in a while. So again, to revisit the use case, it's all about subscribing data to an Mosquitto MQTT broker, using the Pi adapter for MQTT, and sending that data into OSIsoft Cloud Services. Okay. So these are the 6 steps that we're going to be following for the next 45 minutes. As a first step, we're going to see how we can configure Pi adapter for, we're going to see how we can going to configure Pi adapter for MQTT to subscribe data from an MQTT broker and send that data into OCS. Step 2, we will see how those streams are created in OCS. I will configure the metadata rules, which is all about adding metadata to those specific collected streams. Next, we move on to configure an asset type, configuring asset rules, monitoring and sharing your assets, and finally, visualizing those assets using OCS Trend and using Grafana. With this, I'm going to shift to my virtual machine where I have an Mosquito MQTT broker already running, subscribing the data uh, which owes where a set of sensors are publishing data through a simulated app into that specific MQTT broker. Let's get there. Okay, so with that, I'm going to navigate to my screen where I can walk you through. Okay, again, to revisit the steps, I'm going to just go real quick. Oh, sorry, not this one. My God. To revisit the steps, I'm going to walk you through these different steps for the next 45 minutes. We'll start off with step one. It's all about configuring the Pi adapter for MQTT to subscribe data from MQTT Broker and sending that to OCS. So for this, I'm getting into my virtual machine, which has got a bunch of services, which has got the Mosquito MQTT Broker installed, as you can see, and I've also got Pi adapter for MQTT installed. Now, as I said before, there are about 10 mining trucks, and each truck has got about 10 different streams, and there is a simulated application running in the background publishing those streams of data into the MQTT broker. And I can see that using a client called MQTT Explorer, where I can see fleet has to be the super topic. And I got trucks ranging from truck 101 all the way to truck 110. And if I click on a particular truck template, truck topic, so I can see the list of those attributes over here. Um, list of those attributes, right? So if I take a look at these attributes, so I can see those attributes being published, namely the after cooler temperature, its current status, engine coolant temperature, a bunch of different variables specific to a particular truck. In total, there are about 10 attributes per truck that are being published into the MQTT broker in real time. So I have this Mosquito MQTT broker that has all the where the data from these 10 trucks are being published in real time. Let's see how we can use Pi adapter for MQTT, which can subscribe to this MQTT broker and send that data into OCS. So Pi adapter for MQTT, um, as I explained before, is one of those data collector mechanisms, data collector software that allows you to connect to that can be installed either on Windows or Linux and can talk to data sources beyond the conventional control systems. So this adapter has been recently released. So we're going to leverage that particular adapter so that we connect to that specific MQTT broker and send data to OCS. So Pi adapters can be managed either at this point in time, there is no GUI or graphical user interface available for you to manage and configure Pi adapters. You will be relying on completely on REST API calls to administer as well as configure. There are different utilities for you to help you with that, such as curl in Linux, curl, Postman in Windows, and so on. Today, we're going to use Postman to see how we can make those REST API calls to be able to configure the Pi adapter for MQTT. So as a first step, so have this Pi adapter for MQTT installed here, which is running as a service under the name Pi adapter for MQTT. Um, so once the service is installed, I can make a GET request to understand whether it is running. So as you can see, it returns me a JSON response telling me um, the different components, is buffering status, and where it is egressing data to. So similar to a Pi interface or a Pi connector configuration, uh, you would first be configuring an instance and point the data source and point the data items and point the destination targets. It's very similar how you would configure a Pi adapter as well. So as a first step, I'm going to configure a component. What is a component? A component uh, is analogous to an interface instance where you're creating an instance of the adapter of a name of an ID. You give it a component ID called MQTT1, and you're going to reference that component ID going forward to point to a specific data source, point to the specific data items, and also the specific egress endpoints. So in the interest of time, I've already constructed this component body, um, which is all documented in the manual. So I'm going to make a put request and make a send, and it is going to return me a response. Now I can validate whether my component has been successfully ingested into the system by making a retrieve component call, by making a get component call against the adapter configuration. And if I do a send request on that, so it retrieves me that this component has been added into the system, into the adapter configuration. So once I've configured the component, I can go on to configure a data source. Now, as you can see, my Mosquito broker, which is the MQTT broker, is running locally in this particular machine. So, so what I can do is, um, uh, I'm going to set my host name, or this data source facet tells you or requests you to specify the specifications of your data source. My data source is the Mosquito MQTT broker, which is running locally. So I'm going to have localhost as my host name. Is listening at port 1883, as I can see from the uh, MQTT Explorer, which is the client. So I'm going to have the port as 1883. Now, um, stream ID prefix. So this tells you the prefix of the tags of the streams that will be created in OCS. So I can call something of my name, something like Sadin or whatever, Sadin, something like this. So it is going to create me streams of the name Sadin, prefixed with Sadin as the keyword. Okay. So this part tells you I'm all about configuring a data source, setting the host name, the port, and also any stream prefix that I want to go um, before the tags are being created or streams are being created in OCS. So I'm making a send request, so I'm making a put request, and that gets committed to the adapter configuration. So we have configured the component, we have configured the data source. So what next? Configuring the data selection. Now, again, as I said before, we are collecting 10 parameters from each of those 10 trucks. So it's going to be about 100 different attributes. Now, uh, we have a mechanism called data discovery, where the adapter can point to a specific topic and then it emits a discovery file providing you the list of streams or the list of the fields that it sees from that specific topic. Again, in the interest of time, that has been completed and a data selection file has been generated. So as you can see, the topic is pointing to the different trucks and what value are we extracting from that specific topic that goes in as the value field, typically um, aligning with the JSON path expression. Um, so in the interest of time, so this has been built. So you got 100 fields um, ultimately expecting to have 100 streams created in OCS of the prefix Southern. So I'm going to make a put request, um, asking the adapter to accept that configuration, this particular data selection file. Now, the next step would be to configure the egress endpoint. Um, as I mentioned before, Pi adapters can natively egress data or send data to Pi server or EDS, which is Edge Data Store locally, or it can also send data to OSIsoft Cloud Services. So to be able to send data to OCS, again, it expects an ID parameter, it expects an endpoint, more specifically the OCS tenant, where this will reach, and of course the client ID and the secret. In this case, it's a public client ID and a public secret to which will be sending data to. Uh, the credentials which we're using to send data to OCS. So I'm going to make a put request, um, asking the adapter to accept this configuration and use this configuration as means of data egress. Now, so to recap, we have configured a component, configured the data source, configured data selection, and fourth, we configured an egress endpoint. And by that, we expect these streams, we expect the adapter to be constantly looking at the MQTT broker, subscribing data for those 10 trucks, in total 100 streams, and sending that data into OSIsoft Cloud Services. I expect that to be happening right now. Okay, so at this point, let me go back to the presentation and show you where we are with respect to the configuration. So we have just completed step one in terms of configuring the adapter to subscribe data from an MQTT broker and send data to OCS. Our next step would be to log on to OSIsoft Cloud Services and verify whether those streams are being created. Upon verification, we will proceed with the next steps of creating metadata rules, asset type, asset rules, and the further next steps. Okay. So I'm going to log on to OSIsoft Cloud Services, which is cloud.osisoft.com, and I have logged on under my account. Um, and if I walk through a set of features, it's categorized by the different functionalities, namely ranging from data management to data collection to visualization, security, and so on. As a first step, we'll walk in through the data management. We expect under data management, uh, namespaces, it's a collection of different logical resources, sequential data store. It's where we inspect the streams that are being created. Metadata rules allows you to add metadata to those specific streams. Asset rules allows you a functionality to add uh, um, add asset rules, ultimately helping you to automate the creation of assets. First, let's take a look at the sequential data store. Now, I know I've prefixed using Southern, so I'm going to say Southern star, and yes, I can see all those streams being created. Fantastic. Um, I can see those 10, 10 trucks, 10 streams. So in total showing 1 of 50 of 100. So I can see 100 streams. So far I can see 100. Here we go. I got 100 streams created by the adapter just a while back. Now, as you can see, I can add, again, I'm not going to go too deep inspecting into the properties of every stream, but we'll proceed to the next step in terms of how we can add metadata to those streams in bulk. Now, by default, the metadata or or the contextual information for each of these streams, they carry the adapter configuration by default, namely which adapter it came from, the data source it came from, the corresponding topic, and the value field. Now, we can add more metadata fields into those specific streams by using what is called metadata rules. So the metadata rules provide us an opportunity to add to extract some namings from those particular stream and add uh, associate a meaningful name to those streams. So I'm going to say I'm going to pick a stream. So I'm going to say Southern Star, and then I'm going to pick one of those streams as a template. And then here I can say um, I can have a string literal, this to be the name, and then I have a truck ID. This one can be the truck ID, and this one can be the measurement. The measurement. Okay, and I can also break this down. So this truck ID. Then if I say copy, I can choose. Wait for a sec. Sorry for the slide um, deviation. Just getting a slight deviation. Yep, I got this one as a string literal, and then I can choose the different associate the different names extracting from those stream names. So this can be the asset type, and this again can be the asset ID. So what I'm doing out here is that I'm extracting specific points from the specific stream and then associating a meaningful name to that specific part. For example, truck is an asset type. You could have a shovel, you could have an excavator, you could have a dumper, and so on. So to make it generalized, um, I'm classifying this truck to be of asset type. Similarly, you could have 101 ranging from 101 all the way to 110. So I'm going to assign an ID to those specific unique identifiers. So I'm saying asset ID, and so is the measurement. So I've selected a stream, created a pattern, and then I can go ahead to create some mappings, right? So for asset type, I can simply I can extract the name from the stream and copy them to the asset type field, metadata field, and similarly for the asset ID. But for measurement, um, I need to map values. So I can say generate mapping values. Um, Again, this is where you are converting your process named stream into an human readable format, right? So the truck is mapped as an asset type. The numbers are mapped as asset ID. Now, when it comes to measurement, uh, these are all the names of the streams that the adapter sent to OCS. So as you can see, it has got some underscores in there. Now, mostly they are okay. You can still plug in those underscores. There's no issues in having underscores when you want to view them into your client displays, such as Grafana or OCS trending feature and so on. But to make it even more presentable, you can think of getting rid of that particular underscore. So what I'm going to do is I'm going to map, extract those measurements and map it to those specific metadata fields by removing those underscores. And that means I can simply use these as my field names in my client tools. Again, the purpose of this is not to show like how you can remove those underscores and have them a presentable format, but in the field, you could have some really long, weird names. Um, and you could, using this metadata functionality or by going through this process, you can convert your machine readable names into human readable names. Okay. I hope that makes sense. So after I'm happy with the extraction of meaningful keywords from a specific stream name, and after mapping them into specific metadata fields, in this case, the type, asset ID, and measurement, which is all about creating those mappings. I'm going to click next, and then create a rule called something like a metadata rule, right? And then save and execute. And at this point in time, the metadata rule has just been executed. Now, so this metadata rule has just been executed. Now, if I go back to my stream, which was earlier created, and now I should be able to see a list of those metadata fields that we have just added. Remember? So from this, but what we have essentially done in the last 5 minutes is getting an understanding of this particular stream name, extracting keywords from that particular stream name. We have extracted truck from this key name and mapped it to an asset type metadata. We have extracted 101 and have mapped it to asset ID. We have extracted this after cooler underscore temperature and mapped it to a measurement metadata field. But while doing that, we have mapped it to the value after cooler with no underscore and temperature. The idea here is to show you how you could extract some weird names from the streams and make it more presentable, meaningful using this metadata feature, right? So I'll go back to my slide to showcase you where we are at this point in time. So you have just configured metadata rules. By that, I mean we have created the streams, extracted names from those streams, and mapping them to specific metadata fields. With that, we'll move on to the next step, which is creating an asset template. Now, we know that all these under streams together make up the difference, make up all these under 10 different trucks. Would it not be cool if we have 10 different trucks? By clicking on a specific truck, it drills down into those specific 10 attributes. So to be able to do that, we're going to classify each of those mining trucks as an asset template. And we're going to do that as part of the next step. So to do that, I'm going to get into this visualization layer, specifically under the Asset Explorer. I see a drop down under the top left, which allows me to toggle between assets and asset types. Selecting asset types, and um, so the so the goal in hand would be to create an asset type that I can use as a template for the other assets to be automatically generated. Now, again, in the interest of time, I'm going to base my, I'm going to create an asset type based on this pre-built asset type called incomplete truck asset type. So I'm going to duplicate this asset type and call this as Southern ROM trucks asset type. And as you can see, it already has those set of different properties. So it is missing three more properties. So I'm going to add those when you quickly inspect. It has those properties that typically you have in a truck. This process is equivalent of creating an element type in asset framework. We have an element type. You would add attributes to those element type. Is exactly what we're doing. We are creating an asset type called Southern ROM trucks asset type, and we are adding attributes to that specific asset type. And in the interest of time, I have already added 7 different attributes. So I'll show you how I can add the remaining attributes for latitude, longitude, and status. Latitude, and then I'll go to add another attribute called longitude stream reference. And then I'm going to add a status, right? So this means this truck now contains 10 different stream type references, pointing to the 10 different streams that we have. Now, um, asset types also provide a feature called status. And this status, I'm selecting a property, the status field, which I have earlier defined. And this means this will provide me a view. This will provide me an opportunity to view the assets based on the different modes uh, it undergoes. And to be able to do that, we need to add some different operating modes to that specific asset. This could be in the form of a running asset, or the status of the truck could either be running or it could be in the maintenance mode, and or it could also be in the stop state, right? And I can associate some specific legends to to the different mapping values. So once I'm happy with defining the various properties and status for a specific asset type, in this case, the truck's asset type, I'm going to click save and I will have that asset type available. And now this is simply an asset type. No assets are being created yet. Again, to make it analogous to the AF world, this is equivalent of an element type to an extent, right? So once we have this asset type, the next step is to create assets based on this asset type, right? And that brings us to the next step in the process, right? So we have just completed step 3 in terms of configuring an asset type. The next step is to see how we can create assets out of this asset type. Again, to be able to do that, there are a number of ways you can create assets out of an asset type. Very similar, there are a number of ways you can, very similar to the process in the AF world, where you can create number of elements based out of an element template. You could use PyBuilder, you could do manually, you could create some rules, and so on. So today, I'm going to talk about what is called asset rules. And these asset rules are available under data management functionality under asset rules. And these asset rules provide me a way to automate the creation of assets. Let's see how it's being done. So I'm going to add a rule and call it something like certain asset rule. Remember, we um, we did a step just a while back, very similar to this one, but that was for adding metadata fields into the specific streams. Whereas this process is going to help us creating assets out of that specific asset type automatically. So I'm creating an asset rule. I'm going to select an asset type. Um, in this case, the asset type which I've just created, Southern ROM Flux asset type, and continue. And it will ask you to prompt for a stream, and the stream at which, based on which it is built, it's going to be built. So I'm put up one of the streams that I have under prefix. And now, um, in the case of asset rule process, it's again a four-step process. We extract the tokens from those streams or using the metadata fields, and then we will map those tokens to specific values and automatically let the asset rule to create the assets for us. So I'm going to do this. So I'm going to have this as a string literal. And the reason why I'm doing this is because um, I want names. I want these different names to be extracted. So the rest of the stream can go in as this so that I can have have the stream names captured, right? And then all that I'm doing right now is extracting tokens from this particular stream name. And remember, when I select stream metadata, um, because I have earlier created used those metadata rules to create some metadata fields, I'm going to use them. So namely asset ID, asset type, and measurement. Okay. So my token sources are coming in from the stream name. It tells me what stream I should use, and stream metadata, getting me an opportunity to map to the metadata fields which were earlier created. Now, once I'm happy with that, as I can see, we're going to use these sources as a way to construct the name of the assets. Okay. So on the right hand side, you will be seeing the list of tokens that we have extracted, namely the asset type, asset ID, measurement, and the stream name. Okay. And then it prompts ask you to select a token which contains a measurement. We know it. That's hidden into the that's available in the measurement metadata field. So I'm going to select that. And finally, it would ask me to generate mappings. And by this, it's mapping. So it has extracted those tokens. It has extracted these mapping values from the token sources we provided, namely from the stream name and the metadata fields. And it would expect us to map it to the corresponding attribute from the asset type. Recall that we have just created an asset type of these different properties, right? Where we specifically added latitude, longitude, and status specifically added those three different attributes. Now, so we have to explicitly map the extracted token source to the attribute of the or to the stream reference of the asset type. So I'm going to simply uh, proceed with that process. Engine oil pressure, engine RPM, ground speed, latitude, longitude, and status. So as you can see here, the token value mappings that we have extracted from the token sources, namely the stream name and the metadata fields, are being mapped into the stream references of the specific asset type that we earlier created. Once I'm happy with that, I'm going to click next. And this leads me into a page of how I want my asset names to be created. So this is where I tell, hey, look, this is how the names of those specific assets to be created. Now, so I can call something like I would like to have the prefix as southern, and then the token sources are available as as this one, as parenthesis. So I can say if I want the name of the assets to be like southern hyphen truck, and we know that truck is embedded under the asset type token source, right? And then if I want hyphen, I can do that. And then I can be unique by having asset ID that will provide me the corresponding ID for that specific truck, ranging from 101 to 110. So OCS expects each of those assets to be unique. And by doing this way, I'm going to construct an asset name of the type Southern truck 101 going all the way to 110. I don't mind having the same grid as the name of my truck. So I'm going to just do a copy paste of the IDs and the name. All that I need to do is to ensure that the IDs are unique. Once I'm happy with that, I'm going to say next. And this is where the asset rules are running under the hood, right? So as you can see here, it processed 10 different assets. It processed 3583 streams. It looked up all the streams in this particular tenant, and then streams matched 100. That's what we expect because we got 100 streams matching with the prefix Sadin, 10 attributes from 10 trucks each. And then metadata. Remember, uh, we mapped specific metadata fields, couple of metadata. We used couple of metadata fields as a token sources for every truck, so 20. And then the stream references again is 20. So it's done, it's mapped. So this will be the name of the truck that you will be seeing in a while. Southern-truck underscore 101 matches with the expectation. And this automatically maps to the different attribute names, um, stream reference types. For example, southern.truck101.engine fuel rate, 102, 103, 104, and this goes on for the remaining 10 different attributes for each of these trucks. Remember, we created all these tags from using the adapter in the first place. And we have let asset rules to map the fields to those specific streams. Once I'm happy with that, I'm going to say save and execute. And it has executed this one. Its progress is in the running state. Let's give a bit of time and it's going to very quickly get into the executed state or completed state. Very shortly, here we go. It's completed. Now, let's get into the visualization asset explorer to look at the assets. Right? So I'm going to say, and now this is the asset type that we have created, which is Southern. Um, Here we go. Southern asset types. This is the one that we created. But now let's take a look at the assets by filtering by that asset type. So it's still not available. I realize I need to make a refresh. Here we go. So I'm filtering by this particular asset type, which is Southern. And then it's going to show up all these trucks, namely 101 all the way to 110. Remember, all these assets have been automatically created by the asset rule that's running in the background. So I can go inspect one of those trucks and say the properties, right? So we got this metadata, the properties, and the status that we talked about. Now, so I can inspect, I can go for the last 8 hours or for the last 5 minutes, can inspect those various different properties within this particular asset types, within this particular asset. And as you can see, I'm looking at 4 different attributes for this Southern truck 102 for the last 5 minutes. I can toggle between the different trucks and it is going to populate for those different values. I can also take a look at the status tab. Remember, we specifically mapped the different modes a truck can take to the specific status attribute. Now, this will give us an opportunity to look at how the different mode, how the truck has taken the different modes for the period that you specify. In this case, the truck has been under maintenance for this period of time and then be in the running state for this period of time, um, and helps you to quickly diagnose the various operating modes of an asset or a processes. I personally feel that this is an interesting feature to have just because it provides you a fantastic opportunity to look at an immediate quick view of the different statuses of your assets or processes. Now, um, on the left hand side, I can also filter the assets by their different statuses. For example, I want to share this with one of my maintenance engineers. I want to share a list of all the bad or warning status ducks um, for a specific template to my maintenance engineer so they can take a look at it. I can do so. All that I need to do is to select my specific asset type, which is Southern Remote Monitoring Trucks asset type, and I can choose my warning and bad status trucks. So this is a view which is going to be dynamically updated every time when a truck enters into a bad or a warning state, right? And on the top right, you will see share filtered assets, and I can copy that. That's a simple URL. I can copy paste that URL over here. Sorry about that. And then it gets me into that specific view straight away, having providing the maintenance engineers an immediate quick view of the trucks that are in bad or that needs attention. All right. Um, so with that, let me switch to my slide and show you where we are at this point in time. So we have seen how we have configured the asset rules so the assets were automatically created. And then we also seen how we can monitor the bad or the warning status mode of trucks and share them as a simple URL to your maintenance engineers or to an interested stakeholder. With that, we'll be moving on to the final step of this process where we can learn how we can visualize those data either using OCS Trend as well as using Grafana, which is step 6. Now, so and one of the features of OCS functionalities of OCS is the visualization layer, and I can get into the trend functionality. Right? So I can either search by assets or I can search by streams up to me. Right? I can search by assets or streams. So for example, if I search by stream, I can say Southern Star. It gets me all these assets, all these streams listed out here. Um, Again, I'm going to provide you a very quick sneak peek of how you can use this OCS trend functionality to visualize those events. You can get a deeper understanding by going through the specific documentation. So as you can see, I'm selecting the truck 101 after cooler temperature, engine, um, and then, or maybe not. I can also do this from the streams perspective. Alternatively, I can also do this from the assets perspective, something like Southern. And then if I say this after cooler temperature, engine cooler, and as you can see on the left-hand side, it gets sorted by this specific asset. So I may be interested to look at the various parameters of a specific truck 101. And once I'm done with that, maybe I'm interested to look at a different asset. So I can use what is called swap asset. I can simply swap assets to a different truck, and the trend is going to automatically populate for you. So I'm going to swap asset from 101 to 106, say continue, and it's going to auto populate. OCS also provides you an ability to use trend cursor sort of functionality where you can highlight those trend cursors and gets you to do some basic statistical computations for you for those different process variables in question. In this case, it gives me the minimum, maximum, average, and the delta for that specific for the time period that's been highlighted for those different specific streams. Now, um, in addition to that, I can also for example, do a performance comparison check. So I can do that so for example, if I want to compare uh, after cooler temperature between two different trucks, how do a process value parameter compare between different trucks? I can do so. So all that I need to do is to add the similar parameter from the truck of interest. And as you can see, so let me remove this. Let me remove the trend cursor. And as you can see, I've highlighted the after cooler temperature for both these different trucks. And I can do an immediate comparison between how these two different variables of the same variable behaves for the different trucks. And I can also use as that as a base and compare between the different trucks as we saw earlier. Okay, um, so that is what that's a quick sneak peek of how you can visualize your OCS streams using the trending functionality. So with that, let me move on to the final portion, which is using Grafana. So As we have seen how we can use OCS to manage your streams, organize, build assets, auto create assets, and also to visualize them. Um, because OCS is completely accessible through REST APIs, we have a sample code in a GitHub sample project, which allows you to develop your own plugin, install a custom plugin within your Grafana dashboard, and have those OCS streams to be accessed within your Grafana dashboard as well. So again, in the interest of time, I have launched this Grafana dashboard much early in advance, but I'll quickly show you how how the OCS comes in as a data source over here. So if I collect data sources, I can see the OSIsoft Cloud Services has been added as a custom plugin within the Grafana portal. And all that I need is to pass in the corresponding credentials, client ID and secret, corresponding namespace where I'm involved in. And once that is all done, uh, I can validate whether my connection to the OCS from Grafana is working. Yes, it is. And then I'm good to go to create a dashboard. So within Grafana, I can create a dashboard. And in Grafana terminologies, a dashboard is nothing but a collection of panels. And I could add a panel. And in this case, I could select my OSIsoft Cloud Services as the data source. And when it comes to stream, I can do uh, a stream that we have just created, southern truck after cooler temperature, right? And I can choose time series, I can choose a time range for the last 5 minutes, and it's going to simply show me, right? And I could add on those multiple panels um, within those. Um, so for example, again, I can do a southern, and then maybe the status or the engine coolant temperature as a radar, as a stat, perhaps for the last 5 minutes, your data, but that's okay. Okay, I think this is coming in. Okay, I think it's waiting to upload for that particular tile. So as you can see here, you can visualize the streams that we have just created in OCS using Grafana as well. So with that, I'm going to toggle back to my slide and walk you through the summary of steps that we have just discussed. Um, we started off to configure an adapter to subscribe to an MQTT broker and send the data to OCS. The use case was to collect data from 10 different mining trucks, 10 variables per truck, which were publishing their data to an MQTT broker. Once we got the streams created, we went ahead to configure the metadata rules. We configured an asset type as step 3. We configured asset rules to automate the creation of assets. And we also seen how we can monitor and share your assets simply as a URL to the various stakeholders of your organization. Finally, we also saw how we can visualize your assets using OCS Trend as well as using Grafana. So with that, this comes to a completion of what we targeted to cover. I hope you all enjoyed as part of this show. If you have any questions, feel free to reach out to us. And if you have any questions in relation to Pi adapters or OSIsoft Cloud Services, feel free to reach out to us. Again, I thank you for uh, for listening to this session, and I hope you have a great day ahead. Thank you.